Welcome back, friends. Our topic is inverse functions, the relation between dy dx and dx dy. Friends, watch the complete video for a proper knowledge. If you are new here, please subscribe the channel and press the bell icon for the future updates. Friends, let y is equal to fx be a 1, 1 and onto function. Okay, this is 1, 1 and onto function. So since y is equal to fx is considered as 1, 1 and onto function, so the function, inverse function f inverse of f exists, isn't it? We know this definition of inverse function because the function fx is 1, 1 and onto considered, so the inverse f inverse of f exists. If when solved for x, the relation of y is equal to fx can be written as x is equal to f inverse of y. Okay, x is equal to f inverse of y. In the relation y is equal to fx, x is regarded as the independent variable. This is independent variable, and in this relation x is equal to f inverse of y, y is considered as the independent variable. Okay, now by differentiation we get dy dx from this one, dy dx, and from this one we shall get dx dy. Now friends, the relation between these two differential coefficients can be obtained in this process. Now let us consider that delta x and delta y are respectively the increments of x and y. Okay, x gives the increment delta x and y gives the increment delta y. These are the increments. Okay, now we can write delta y delta x into delta x delta y is equal to 1. So taking limit of both sides when delta x is tending to 0, we get limit delta x tends to 0 of delta y delta x into delta x delta y is equal to 1. Okay, so a limit delta x tends to 0 of delta y delta x into limit delta x tends to 0 of delta x delta y is equal to 1. Okay, so friends, now since delta y is tending to 0 as delta x is tending to 0, so we can write from this one as dy dx into limit delta x tends to 0 delta x delta y is as dx dy. So we are getting a relation. The relation is dy dx into dx dy is equal to 1, which is the required relation. Thank you. Have a nice day.